Alright, here we have NET-200, and this would be 9/7/16. It'd be Wednesday, and we are on week 2, day 3. Alright, so what we took a look at, we have PCs here in the lab, we have end devices, clients, and then we have intermediate devices. We've got a switch, a multi-layered switch, and then we have a router and a router. And this is going out to the internet. This comes into the main campus, intermediate device, firewall, intermediate device, multi-layered switch, intermediate device, a switch, and another intermediate device, an access point. We have phones that can connect wirelessly using Wi-Fi to the access points. Or they could use another wireless and connect to whatever might be a 3G or 4G network, LTE. So this would be on their data plan. In here, it'd be Wi-Fi, and they'd be using the college's resources to, if they went all the way out, to connect out to the internet up here on top. We talked about some detailed things here. We talked about network interface card, RJ45. We have a connection here, connects us into the switch. This is a logical view of the network, except that we don't give the specific IP addresses. I'm not giving specific, but we talked about the router, finding the best path using IP address. Simple example, this router figures out if it should go this way or this way when the packets come back in. We've got a printer connected here to the network. We have a switch, 100 million bits per second. We have a gig connection here to the multi-layered switch. The multi-layered switch functions both as a switch and a router. Off of here is work server 1. The wire connecting this, Cat5e. And then we talked a little bit about the physical address, media access control, or MAC address, in all of the devices, and how a switch keeps track of that, and that's how it knows which device is which connected to it. Alright. This is the other half of the picture. First of all, down below here, you see the connection to a tower. Usually measure how much data you're going to use, bytes, your data plan. You know, maybe it's 6 gig. Connect to some tower, and then that tower connects in to the internet, if that's what you're doing. We got an example here of a wide area network. Typically a service provider, but doesn't always have to have a service provider. Charles City, NIACC, is connected to Charles City, so we have this WAN connection into the internet that allows us to connect. We also talked about a WAN. Mercy goes through some type of service provider that connects to Nova, Michigan. That's near Detroit, and that's where their main office is at. Mercy Hospital here in Mason City, and they have a connection between those two, and they just pay a service provider rather than go through the internet. We have data centers at Google, and they connect into the internet. Okay, local area network, usually in the same geographical area, managed by one company, school, location. You got land in your house probably managed by you, even though you may do little or not with that. And then we talked about 5. Typically over a larger geographical area. And typically have to go through a service provider. Not always, but typically. Then here's the big picture. So we have end devices or clients, and then maybe we have a server over here at Google. We can literally go through the internet to there, and then they can send the information back. Alright, the internet combination of all these routing devices to route the packets of information through. Typically based on some IP address. Routers in the internet find the best path. For example, NIACC here can be connected to their Charles City site. We talked about wireless phone, could connect through LTE to here, and then if they need internet services, into here. Or people with their phone can connect in through NIACC using the Wi-Fi. A physical diagram would give the specific connections. For example, in the classroom, we have a PC. The PC is connected to a box. That box has a cable, goes up to a patch panel. From the patch panel, there's a cable that literally then connects into the switch. Then the switch has a cable going to the multi-layered switch. Actually, it goes to another patch panel, and so forth. That would all be the physical setup. You got the patch panel for all those connections. Okay, this is the little box sitting on the table in the classroom. And the NIC here. A logical diagram is a little bit more of what we typically draw on the board, but technically it usually has the IP addressing with it also. And you're more concerned about how you view it using IP addressing, how you look at the networks, and how they interconnect through routing devices. Physical diagram shows the actual connections and how they're actually connected. We refer to this topology. That's a T. It's a little hard to see. That's TOPOLOGY. Topology. A couple other terms. The Internet. This term comes from the word internetwork, and it really, the Internet is this vast connection of other networks. So things are actually not stored in the internet itself, it's stored in all these clouds. So you could be at home and you can connect to Canvas, Canvas talk back. That creates a WAN. The internet allows WANs to be created. Well, the internet itself really isn't a WAN. But the internet uses these technologies. A browser, which uses HTTP protocol, that allows us to connect websites together. You can take that same technology, build it within your business, and have an intranet. It's like the internet. It's like the internet, but typically it's private. Everything connects inside, and you can use this technology, browsers, HTTP, and you can have something like here at the college, you have a portal, intranet. Now, if you want to allow other companies to connect in, for example, some companies would connect in just to track their product, The college may let other colleges connect in to look at programs or whatever. That's usually referred to as an extranet. You allow some type of connection into your intranet. The intranet is usually private. People can't get in without password and so forth. Of course, the internet is this vastly open ability to connect. So here again, I guess this is a repeat of where I already had talked about this connection here. We talked about wide area networks. We talk about local area networks in the same geographical area under usually one management. Wide area network often has a service provider, doesn't have to, and it's over a larger geographical area. For example, here we mentioned earlier you could have a service provider. Alright, that is it.